So welcome today. My name is Liam Kavanaugh. I am a program manager with the Azure search team. That means I work in the engineering team, work closely with marketing, customers, engineering, trying to make sure we get all the features that make sense into the product. And of course, today I'm talking about Azure Search. And just to get a little idea of the crowd, can I get a show of hands? How many people here work in IT? Okay, and of the crowd, how many of you would feel you're pretty comfortable as a developer, using .NET technologies, things like that? Okay, good number, excellent. So I think what I'm going to go through today will hopefully be beneficial to you in the crowd because, to date, we've been talking about search from the perspective of, consumer interaction. I mean, grab your smartphone. Take a look at the apps that you have installed in there. And think of your favorite ones. How many of those have some sort of search box in that application? And I bet you it's a large number. Of all the apps that you use, whether it's Yelp or if you're going to, Wikipedia, there's always some sort of search box. If you go to your favorite e-commerce retail site, you typically go straight to the search box. So having a great search experience is pretty important. And what I want to explain today is, from a business perspective, one of the things that we're starting to see is that more and more organizations are starting to look at search as a natural way to let their users explore and navigate the data that you have in your organization. And if you think about it, for me, I've done SQL forever. So, to type in a SQL query is, I love doing that. But I know also that the users that I write my applications for are not necessarily experts in that. They prefer to use something like Excel or search because, they go to Bing and Google all day. So it's much more natural for them. And that's what I want to kind of get across today and start to see if I can get you thinking are there some types of applications? Do you have data in your organization that it makes sense to consider using search as a front end for the navigation for your users? So what is Azure Search? Azure Search is one of the newer services within the Azure platform. We went generally available. Our first V1 was announced at the start of March, so just over, I guess, a month and a half, 2 months now. But the purpose of it is to make it easy for developers to add a great search experience to their websites, mobile applications, whatever they might be building. So if you think about it, what does it mean to have a great search experience? For most people, when you think about search, the first thing you think of is, okay, I got this search box, someone puts in a word, and it goes against my content, and it finds a match for that and brings them back some matches. And yeah, that's the start of it, but there's a lot more to it than that in order to add a good search experience. And it really comes to things like Google and Bing, where people are used to a certain level of quality of search. And if they don't get it in your app, they get frustrated, and they'll leave, or they'll just not use it. So if you look at some examples here, one of the first things that a user might expect is this idea of type ahead. So as they're typing into that search box, it looks through your data, it looks through your content for potential matches based on the letters that they're typing. This is called type ahead or suggest. The other thing that's pretty important is the idea of handling spelling mistakes. You can see in my example here, I typed MAN, and this is just a made-up customer management system that I put together. But it's the idea, as they're typing, it shows potential matches for contacts and accounts, but it also brought up some potential other matches, like it brought up Mary instead of, even though it was R instead of an N. If you look at the very bottom account, it was Menlo Park Outfitter. So, slight spelling mistakes can still link people to what they are looking for. And this makes sense, right? If you're typing in a customer's name, you may not know how to spell it properly, and if it looks like there's nothing there, well, that's frustrating. So being able to handle these things automatically in an easy way, kind of makes sense. And then if you go into the search results page, there's a lot of things that come in here. Some that are just not visible to the user, and then some that really help with the exploration. The first is this concept of facets. And really, all a facet is just an aggregated count of the categories based on what you've searched. You see this when you go to Nordstrom.com or Newegg or any type of site where you're looking for a product and you want to drill in maybe by manufacturer or price. These are facets that allow you to click on them and to drill in and find what you want. In this customer management system, maybe you might say, I want to have types, be able to filter by contacts or by state or by the vertical so that the user can search what they're looking for and then drill into it really, really quickly. So tying facet with filtering of results is pretty important. Paging, we see that in pretty much every search result because you probably don't want to show everything. And hit highlighting. I don't know if you can see this very well with the screen, but one of the things that we can do is we can provide back hit highlights or a snippet of the text along with a highlighted section to show you where in that content we found a match for what you were typing. Here you can see some examples of where we did that. And you can actually provide custom code so that, like you see here where it's doing a bold and an underline for my content, it brings that back automatically and just show it. So it automatically displays it. Sorting, you could think, I want to be able to sort it by contacts, by, the revenue, whatever makes sense. But another thing that's really important, and this is, some people say, well, why don't I just throw in a Google or a Bing toolbar and I'll be done? First of all, assuming that those engines actually had access to your data, this is the biggest reason why people will look at using a search service. And it has to do with the tuning of the index. And there's a couple of reasons why you would want to do that. First, sometimes it's for business value. If I'm running a retail site and someone searches for black shoes, and I have 1,000 different types, well, you know what? I might want to boost up the ones that I have higher margins on or that provide higher revenue for me. So it's relevance, but it's weighting. So it's not sorting, it's boosting up items based on what's important to you. In this case, I can do tuning based on the user experience. For example, I can make it so that if I'm searching and if you find that word in the customer's name, that's more important than if you find it in the company description, right? So you can do all this boosting. You can do boosting based on values or time, or even, as you can see in this case, geospatial. We tie not only the textual search, but also geospatial as well. So that when you're searching, you can do things such as, show me all of the customers that are within 100 kilometers of myself. Or pass in a polygon, a region that says, show me all of the companies that are in this region, because I'm flying out to this area and I want to know which companies are in that area right now. So tying it in from a spatial perspective can be a nice way of navigating. And I think we're seeing more and more that the visualization of mapping is a nice way for people to drill into that data as well. We've actually even seen some pretty cool real estate applications where they actually let people draw onto a map the area that they're interested in, and then that comes in as a query, and then we say, here are all of the houses that are located within that spot. So there's a lot of really cool things that you can do from that side of things as well. So he's talked about some examples, e-commerce. I actually, coincidentally, I hope you don't mind me pointing out, Ron from Hy-Vee Supermarkets is here, and he was nice enough to actually show me. They have, let's see if I actually bring it up here. He's showing me the example of their site, Hy-Vee grocery stores. I think it's a couple hundred grocery stores in the Midwest area, and so they've been looking at using search so that from their supermarkets, what they can do, the users can actually search for products and actually do it. You see on the left side here, they're also using faceting, right? They're showing the counts there so that you can drill in. I typed in fruit, which is obviously a pretty wide category. It shows a lot of results, but I could drill into to find whatever I wanted. So this is a really awesome. It's been thank you for letting me show that, Ron. So this is a great example of an e-commerce site, but it's not always just retail. We have Auto Trader Canada, huge used car marketplace. They use it to let their millions of users search for used cars and then find a car that's within a certain proximity, geospatial, right? So it's pretty interesting to try to tie this together. User-generated content site is another big reason. Think of your organization. Do you have a support system? Knowledge base articles that you want to be able to search through. Well, sure, full-text search makes a lot of sense, but even scoring, you could apply that where you actually say, search for this word, but if this article is more recent, was created more recently than another one, give it a little bit more weighting, more boosting. If you find that text in the title of that document, that's more important than another one. So people in a lot of organizations are starting to use this search service for a way of putting in their content and then searching through that as well. Oh, and by the way, I didn't mention this. If you have questions, feel free to ask me as you go through. I had these spotlights on me, so I'll try to see it. But if you have a question and I don't see it, feel free to throw something at me. I actually see there's a question there.
Is there any Microsoft service or website that is currently using Azure Search?
So the question was, is there any Microsoft group or product that's actually using Azure Search? Yes. So actually, the vast majority of the groups, and surprisingly, even Bing, is using Azure Search for different purposes. Some of the ones you may be familiar with are Photosynth, if you've ever gone to that site, where you can upload different pictures and it stitches them together in a three-dimensional view. They use it so that you can search and do geospatial to find synths in different areas. There's a number of different, the Channel 9 is using our search. There's Office Labs has some projects that are doing it. Halo is using us for Halo Waypoint. So when you're playing games and you want to search for previous games that have been recorded and played, you can do that. Skype is using it for a bunch of things. Yeah, we probably have about 60 different groups internally that are using it. If you want some more, I could go through, but definitely quite a few. All right, let's keep going. And finally, business applications. That's really what I'm here today, to try to make sure that I can get across that maybe there is some data in your organization that might make sense for you to leverage from the search perspective. So let's finish off with the business side, the OR side, and get into a little bit more of the technical detail of what Azure Search is, how you create it, what you do with it, how you get started with it. So the first concept you need to be aware of is this thing called a search service. This is a thing when you go into Azure and you say, new, I want a search service. It's a kind of a unit of capacity. You say, I want this search service in this data center. I want to tie it to this Azure subscription, and this is the scale of it that I want. This is how big I want it. And so you can choose between two different tiers. We have a free tier. This is a search service that it only allows you to put in 10,000 documents, but it has all the functionality. So it's great because you can test everything out for free. No problems from there. You just can't do any scaling, and you can't go past 10,000 documents. The other option is to create a standard search service. And this is where we give you dedicated capacity for your search. And not only is it dedicated capacity, but it is stackable capacity, so that as your company grows and needs to handle more queries per second, you can add in more units for that to handle that. As your index grows and it grows beyond what can be stored in a single search unit, you can add in additional units to grow and handle that size as well. So it's very elastic, and it's to the point that you can actually just go into a portal, move a dial, and we will automatically allocate that space. And that's a big thing. I don't know how many of you have ever tried doing search. There's some really awesome open source technologies like Elasticsearch and Solr, all built on Lucene. Actually, by the way, under the covers, we actually use Elasticsearch because it is awesome. But one of the things that we hear quite often from these people is that although they're really capable and really flexible, the management of them can be difficult. Putting in a small amount of data and running some queries is typically pretty simple. I've heard people get going in 10 minutes. Like, it's that simple. But once you start getting more content and having it span over multiple replicas, multiple machines, and managing it from that perspective, it can get difficult. And so that's one of the things that we, as a platform, as a service, try really hard to take on and make it easy for you so that you don't need to worry about the scale. If you need to scale up, you scale up. If you don't need that capacity, go down. If you need to worry about Black Friday, U.S. Is a big e-commerce day in the U.S. For Black Friday, well, you just get more load, and at the end of that, you just scale it back down. That auto trader company that I mentioned before, they actually do it throughout the day because they know that their load comes in. From the East Coast, they start getting a huge load, and then as it gets throughout noon, West Coast starts getting more searches, and then it slowly ties down. So they're actually working on it so that they can scale up and scale down throughout the day, so that the hourly billing makes it even more effective for them. So that's an example where the Elastic really helps them. And we talked about scaling. So why don't we take a look at what this means? So let me bring up the portal. Hopefully it hasn't logged me out. And this is where you go. If I just zoom in here, you can see the URL is actually https://portal.azure.com. You can sign up if you haven't already, you can sign up for a free trial account and create a free search service and do all that. But all you need to do to create the service is just choose New. We're under Data and Storage. And choose Search. Give it a name. See if I can come up with one that hasn't been used. Good. And here are those tiers where I can choose between the standard and a free tier. I'll just do free for now so I can create it quickly. Hit save. Let me try that again. Nope, not being nice to me. Let's try this one. Yeah, that's right. Good old portal, not being happy with me.
Is the service in preview mode?
Nope, this is real. This is live. Yeah, I think it's just being slow. Let me just choose one here. That's good enough. Try it again. Free. Select. There we go. And choose a location. So this is where we have the data centers. We have them around the world. Europe, Asia, US. So we can choose West US and go and create it. So a free service usually takes about 1 or 2 minutes to create. I'll do that baking show thing where I'll actually open up one that's already been created. And this is the one that I'll be using throughout this demo. So this, by the way, is a dedicated, a standard service that I've created here. It's in the West US. You can see here there's a number of different indexes. I'll tell you in a minute more about what that is, where I've actually loaded data into it. And there are a number of different properties here that we can see. So if we look at here, I have the key. Our Azure Search Service is an API-based service. So you interact with it using either REST API calls, or you can use our .NET library. But in order to authenticate yourself, you need to have a key. So this is the way that you do that. You take that key and you access the service that way. And you can regenerate them. Sometimes, if you don't want to have your users have administrative access, maybe you have a JavaScript client and you want to be able to let them access the service directly, you can create what's called query keys, and those only allow them to do read-only access to the search service. The other thing that you can see here is, let's go under All Settings here and look at the properties. Here's the URL of my service. I'll zoom in there so you can actually see it. So my search service name is azs-liamca.search.windows.net. So whatever you create your service, that will be the name. And that's the URL where you make your calls to interact with your service. So we'll see that quite a bit as we go throughout this. So that's all there is to really creating it. But the other really cool thing is this idea of scale.
Is this in the Gov Cloud yet?
The question is this in the Gov Cloud? And it is not. We have just, we actually, as I mentioned, just went generally available in March. There's a lot of compliance work that we still need to complete before we're ready for the government cloud. So the answer is no, but it is high on the priority for us to be able to do that as well. So back to this part right here on the scale, there's a number of different ways that you can scale up the service. So right now you have this idea of one search unit, and I can scale it up. So if I want to have more replicas, and a replica, you can think of that as like a copy of your data. So it actually copies it over to multiple different units, and we do the load balancing. So by adding in more replicas, that gives you more queries. It allows you to span the number of queries over multiple different indexes. And we do that for you. You move it to replicas, we'll create the copies, and we do the load balancing for you. And by the way, this is also the way that you can get high availability. Because if you have 2 replicas, 2 copies, then you can have read high availability. And if you go to 3, then you can have write high availability as well, so that you can actually get a service level agreement out of that. The other way that you can scale is by partitions. So we can scale this up to 12 partitions. And what that does is, unlike replicas that it copies it, what it does is it actually splits up your index into chunks. So if you have 1 partition, you'll have it as big chunk. If you go to 2, it splits it across 2 units. So the index, gets split, so we can allow it to load more content, add more storage space to it over those additional partitions. So more partitions not only allows you to handle more storage, but another benefit is that you can also ingest data, upload data way faster because it spans it over multiple different units. So of course, the more units you have, the more it costs, but it does allow you to scale based on your needs. And it's hourly billing, so you can scale it up and scale it down however you need. Okay? Any questions on that so far? I'm going to go at the back. Please correct me if I'm wrong. I believe the question is, the threshold is 15 million documents. Is there a plan to increase that? Did I get that right? Yep. Okay. So it's 15 million documents per partition. So you add a second partition that's 30 million documents. You can go up to 12 partitions. So that's the limit for a single search service. But if that's not enough for you, we in engineering, we can actually allocate what we call the extra large search services that multiply that by 4. So instead of 15 million per partition, it's 60 million times 12, which goes up to 720 million documents. And by the way, you can think of a document as like a row. If you, I don't know how many of you have used SQL Server, probably a lot of you. Think of a document as like a row. It's got fields or columns just like that. Okay, did that answer your question? Okay. I thought there was one other. Oh, yes.
Does it support partial search when one partition fails, is down? Is search still available, or does it need all partitions?
Okay, so the question was, what happens if one of those partitions goes down? Does search go down? And the answer to that depends on what you chose for replicas. Because if you only have 1 replica and that partition goes down, yeah, your search is down too. But if you go to 2 replicas, that means that it's a copy of your partition on another unit, which means that if one of them goes down, we can still search it. And if you have 3 replicas, then we can actually do write, because the way that it works is that if one of them goes down, then, well, we can still write to the 2, but let me step back. So if you have 2 replicas and you're writing to it and one of them goes down, well, technically we could still write to it, but we are worried that if that one goes down, that all that data that you wrote to it would be gone, right? So that's why in order to get write high availability, you need to have at least 3 replicas. Okay, but for read, you only need 2. Answer your question? Okay, cool. Yeah. All right, cool. Let's keep going. So we understand now what a search service is. It's that unit of capacity. It's the data center that you've tied it into. Now, let's talk about what is a search index. And since I'm from a SQL Server background, I like to kind of map it to the idea of a database. And you can think of an index kind of like a table. an index is the container that holds your data. It's got these things called fields. Just like in SQL Server, you have columns. These fields have properties, just like in a column. We have different types of properties, but it has that same concept. You can query an index, just like you can query a table. You can upload documents to that index. You can make changes to it, delete them. So it's a very similar concept to it. So don't confuse it with a SQL index, but it is a similar concept to a SQL table. And we use this because this is kind of a common terminology that's used in the search field. But I like to map it just because that's a good way I find to think about it. So we create a search index, but how do we get the data into this search index? Now, you probably have data. Maybe it's sitting in SQL Server. Maybe it's sitting in some other file system. Maybe it's in table storage. It doesn't really matter. We have two different ways that you can get your content into Azure Search. The first is using our API, where you simply just push the documents to us. You format your content into a JSON document, and then you make a REST call or use our .NET client to actually post that content to Azure Search. So that's one way of doing it. The second way is using pull. We call them indexers, but some people think of it as like a crawler. And this is something that it's almost like a no-code solution where you don't have to write the code to pull it. All you do is you configure our Azure Search indexer, point it at your store, and then we will automatically grab that data that you've told us to, bring it into Azure Search, and then if you want us to, we can make it so that on a scheduled basis, up to every 5 minutes, we can check for changes and bring them in. So we've just started creating these indexers. So far, we have them for Azure SQL, SQL Server on Azure VMs, basically any publicly accessible SQL Server, and also Azure Document DB as the initial stores. We're starting to look into document cracking. So if you have your documents, Word documents, PDFs, whatever, on a, say, blob storage, we are looking at being able to process that and bring that into Azure Search as well. That's not there yet, but if you're interested, we'd love to hear your feedback. And we're looking to kind of expand it to other stores. A question?
What about SharePoint installations, either on-premise or 365?
So the question is what about SharePoint on-premise installations? So is the question, what if I have this on-premise SharePoint data and I want to ingest it?
Basically, to combine,
Data.
because you can do the search in 365 still.
Mm-hmm.
But if you want something that combines something from here and something from there, kind of combine everything in one place,
Yep.
is that a good solution?
Yeah, so I'm going to kind of repeat what you said, just so everyone hears it. So what happens if, you kind of gave me the idea of like if data is from multiple different sources, and you want to combine it together and make it available in Azure Search. And that's actually really common. Unfortunately, it's not something you can do with the indexer automatically. This is something that would need a little, work on your part to actually query that data, merge it together, and then using our push API, send it to us. We have seen a lot of people starting to look at creating connectors for Azure Search for different ways. So I think it's a matter of time before it'll kind of expand. But for today, the answer to that is, unfortunately, it's more programming on your part to get that data and push it to us. Now, it's just over HTTPS, so it's pretty easy to push it from wherever you need to. And we have actually a lot of good best practices for some common stores on how to do that, if you're interested. Yeah, we'll do one more question.
Similar related question around SharePoint content.
Mm-hmm.
So if you have SharePoint content that's indexed in SharePoint, is the index from SharePoint useful here, or do you actually have to process the whole set of content?
Okay, so to repeat the question was on SharePoint. If you're using SharePoint Search and you already have the data in there, can you leverage this in some way? And yeah, the short answer to it is no. We have a completely different format. It's not like you can take a SharePoint index and just copy it to Azure Search and use it. So the answer is no. We have seen a number of people that they have SharePoint on-premise and they want to simply just push some of that to Azure Search to use the functionality in the cloud, make it accessible. But once again, since we don't have an indexer for it, it is a matter of programmatically getting that data and sending it to Azure Search. Okay? All right, just for a matter of time, I might just keep going on this because there's a couple things I really want to show you. And so, in fact, a cool Cortana demo that I really want to get to. But just to summarize, the push, more coding on your part, advantage being that it allows you to get much more real-time updates to your index. As the data changes, you can push it to us as quickly as you want. You can send them in batches to be more efficient, but you push it, and then it'll become available in the search really quickly. The pull, or the indexer, much more convenient, much easier. Downside being that it can only run as often as every 5 minutes, and there are only a few data sources that are available for right now. So let's stop that right now, and I want to show you a couple things. So the first thing is that over here on the portal, so you can see here I have a number of different indexes that I've created already. And I can go in here from the portal and just visually go in and say, I'll say that. Create a new index. I'll just call it tests or whatever, something like that, and start creating some fields so that this is a nice getting started way of trying out Azure Search so that you can kind of point and click your way through creating a search. Here are all the different fields, all the different field types. Let me zoom on that so you can actually see it. All the different types you can define for it. Over here, you can define the properties for those fields. So retrievable means that when you search it, you can retrieve that in the search results. Filter means that you can filter, like maybe state equals Washington. You can sort it. Facets, remember those are the categories. Yeah, question? Yeah, question is you don't have like a type for PDF or Word, and that's absolutely correct. The way that it works, if you wanted to take PDF documents and put them in today, you need to actually take that text out of that and actually send that to us into a string document. So there's a lot of really good tools like iFilter, Apache Tika, which are awesome technologies for allowing you to look at these documents, extract the text, and then programmatically push it to us. So that's where we are today. But the indexer, what we will do in the near future is make it so that's just done for you. You just point us at your file system, your blob storage, whatever you have. We will grab those documents, and we'll do what Apache does. We'll extract that text from the PDF and load it into one of these string fields for you so that we can do it, but it'll still ultimately be in a string field, not in a PDF field. Answer your question? For the indexer, we're just starting to work on it now, and we're starting to take feedback. So if you're interested in giving it a try, why don't you come up after, and I'll introduce you to the engineer that's working on it, because we try to make it so that people that are interested, we can give you early access to it and get your feedback. So if you're interested, please let me know. I'll take one more question, then I'm going to go back. Yeah, that's the way that we're looking. Sorry, I'm going to repeat it. So what if it's an external link? Would that work? And so, yeah, that's the way that we're currently thinking about it, where when you post a document to Azure Search, you post it with the text. In this case, you would probably post it with a URL reference to where we can find that content, that file. And then, so it doesn't really matter if it's blob storage or some other AWS store or something like that. If you wanted to point it at that, we would then go and grab that, do the processing, and apply it. And there's actually some really cool things that we can do with this because, we're actually thinking this would be the first step for some other cool things. We could do it so that, video. Through the Azure Media Services, they have this capability to transcribe the audio, take the actual text, the spoken word from a video, and get the text of that. So that's perfect for us, right? We could just use that to point it to one of your videos. We would grab the spoken words from that video and index it. So then you can search not only the metadata, but anything that was said in that video. So there's actually a number of others that I won't go through, but this idea of us doing the processing after you post it is kind of one of the next big things that we think we'll be doing. Anyway, so I'm not going to, just for a matter of time, I'm not going to go and create the index that way. I'm going to do it through Visual Studio. And hopefully I can get across that it's actually pretty straightforward to go and create an index either through the portal or through here. And the first thing that I want to point out is that we have this Azure Search NuGet package. If you go into Visual Studio, add a new reference, search for Azure Search, make sure you use it as preview. In the pull down, you can add in our .NET SDK. And then you can do all this great stuff. So the first things that you'll need to do is we need a search service client and a search index client. And then I have both my search service name. Remember, that's AZS-LiamCE, or CA. I can't even spell my name. And then the search API key. Remember when we were looking at that portal, we had that, that long alphanumeric set of text for my admin keys. And I create the client so that I can actually connect to it. I'm going to create an index called AdventureWorks, and I'm going to bring in some data. By the way, this is the data that I'm going to bring in. If I can bring it over. This is from a SQL Server database that is AdventureWorks. It combines, the customer name, the products that they've purchased, and I can actually see here if I go to the right here, for each customer, what I did is I actually created an array. It almost looked like a JSON array of all the different products that they have actually purchased, and I'm going to actually use that as in my search. So this is kind of combining all kinds of different data, my source being SQL Server, and bringing it in. So if we look at what I need to do to create that, I'm going to press F12. I'm going to create the index. I could have done it through the portal. Remember, I was saying here are the different data types. Here are the field parameters, whether it's searchable, is it filterable, etc. And I have this interesting field down here called product names. And sometimes people use this for tags. So if you have a bunch of different tags associated with a document, in this case, it's all the different products. It's a collection, a comma-separated list of all of the products that this customer has created or purchased. And then all I need to do is, after I've created the index, load the data. So I'm going to use the indexer. I'm going to create a data source called AdventureWorks Data Source. And over here, in the definition for it, here's the connection string to my SQL database. And here, after the long connection stream, is the view. It could be a table, but the view that I'm going to get the data from. And we actually can use integrated change tracking from tables to efficiently grab the data. And then after we do that, we just create the indexer that uses this and start syncing it. So let's run this so that we can get some data into it. Oh, I'm going to bring it over so you can actually see it before it's done. It's going to be done. Oh, it's done. All right. So it created the index, it synced the data, and now I have my search index with some documents or some data that exist in it. Okay? So that's a first step. Now, the other things that I want to walk through are some of the capabilities now that we have data. Because now that you have data, you probably actually want to do some searching. So let me show you some things that you can do with that. All right. So here's some of the things that you're going to probably want to do. And some of them I've already referred to. But some of the key features are, well, of course, searching. So you provide some text, you pass that to us, and then we do a full text search, and we bring you back some results. There's that faceting, the grouping, the aggregation of counts by categories that we do, hit highlighting that I was referring to in the example. We'll see that. Filtering, so that you can actually search but limit results based on specific values. Sorting and paging. Projection allows you to limit the results so that it only brings back certain fields to keep it more compact. Counts, and even lookup. So if you want to look up a specific document based on an ID, those are some of the basic search capabilities that we have in the search service. So let's go in now and let's see how we actually get that going. So now that I have data in here, I'm going to use a really simple application. This is an MVC application, and I'm going to walk through kind of some of the things that it does. I'm going to press F5 so you can kind of see it. Bring it over here so you can see it. And by the way, I am like the worst designer for UI, so hopefully you just kind of get the idea of the functionality and ignore the fact that I am horrible at UIs. So this is my AdventureWorks customer management system. And what it's going to do is it's going to allow people to search through that index that I created, and then whatever they search is going to find some valid results and just display it in an HTML table. So let me go in and put a breakpoint on the call. So what we're going to do is once you pass in the string, it's going to call this thing as a controller. This is the server-side code, and I'll zoom in on that in a minute. But let me just walk through what it does. So I'm going to say type in John, because I'm looking for some user named John. And so it passed in that request. It said, from that search box, we passed in the query term, John. Hopefully you can see that. And so that's passed in as queue. And then in a second, it's going to call this search. So I'm going to just do F11, call into the call. This is all the code that it was required to actually execute the search, right? It's going to pass in the search text, which is John. I'm going to search for, I don't have any parameter set for it, and get the responses back based on this text that's being called. So let's press F5, run that, and we can see here are the results that came back from that. So we have, a bunch of different Johns that came in here. We can see John was in the email address over here, so that's why it was kind of boosted near the top. So we can do all kinds of different searches, and it doesn't really matter. Like I can search based on the company name, like toys, and search that. I should get rid of that. And we can see here anything that has the word toys in it. We can add that. So let's go in and make it a little bit more interesting and add in some hit highlighting and some other fun capabilities. So so my computer comes back. There we go. There we go. All right, sorry. So I'm going to put in some new stuff here into this code. So I'm going to go to that feature search, and I'm going to say, change this right here. To this. Well, it didn't tab very well. There we go. So we're going to add in a bunch of interesting things here. So I'm going to, actually, let's get rid of this for right now. So I'm going to do the row counts. So in this parameters, I'm going to say, I want the search results to have that. And remember I was telling you hit highlighting? I want you to do hit highlighting. So whenever you do a search and you find a hit based in either the company name field, the first name field, or the last name, I want you to highlight that and then also do these tags, so a bold and an underline before and after. So in my HTML table, it just automatically formats it really, really nicely. And then, so let's change the view so that it actually accounts for that. So if it gets a highlight, if it finds a highlight, then display the highlight value. If not, just display the original document. And then over here, for the count, I just have a simple little div that just says, when you bring back the count, just display it as total results in that. So that was all I did for that part. So let's see if it looks a little bit nicer. I'll type in, say John. Let's get rid of that breakpoint. We don't need that. And, I should have done a company name. That would have been better. What is it? Bicycle. There we go. So since I did the hit highlighting only on the company names, you see how when I zoom in on here, you can see that it did the hit highlighting with the bold and the underline automatically for me. And by the way, I don't know if you noticed that we actually got, even though I I typed in bicycle. We also found bicycles because we can handle looking for the plurality of the words as well. We'll get into more of that in a few minutes. But this allows us to find a lot more viable results regardless of what they're typing, or even if there are some spelling mistakes in there as well. Okay?
Question for you?
Yeah, question.
You show that bicycle is plural or not. Do you also do things like character normalization? So if I had accents and sort of characters like, say, Spanish-speaking language with accents over the A's or the E's, yeah, do you normalize that? And if I was typing a city name with an accent, it would find it if I was typing it or wasn't?
Yeah. Is it okay if I hold that question for a few minutes? The question was on text normalization, and I have this small section on multi-language support, and is it okay if I just hold that for a minute? Because it's a great question. Great. I'm going to share one more question.
One last question.
Yeah.
You mentioned you do pluralization. Do you do lemmatization as well, or is it, do you have it all implemented?
Question was on lemmatization. Short answer is yes. Can I hold off that one for a minute too? Because absolutely, that is, yeah, we do. But I'll go through that as well. So let me go in, and I'm just going to do in one more thing here. I'm going to do in some faceting so we can put that in. So let me just bring this in. Feature search. Stop the app so I can actually make the change. I'm going to make it so, oh my gosh, this tabbing is not working very well. Let me just, like that. So I'm going to facet based on these fields. So what I want to do is I want to have a little left sidebar that shows the counts based on the company names, the salesperson values, and actually the product names as well. So remember that product names was all of the different products that that customer had purchased, so I can actually do filters based on that. And then whenever they pass that back to me, when they click on one, I'm actually going to go and do a filter. So when they click on, customer name equals John, I can do a filter right from here. So it limits those searches from there. So let me put a breakpoint on there so we can actually see it. And change the code over here to add a div for the result of the facets. And let's run that. And all it does is it just iterates through the facet results. So let's try John again. And so you can see here now on this left sidebar, we have all of the different facets based on the company name, the salesperson, and the products purchased. And if I go and click on one of these, because it says that there's two of these, I can choose one. And you can see now it came into this breakpoint, and it says the filter field is company name. And I want to press F10. And I want to say where company name equals this value right here. So we can run that, and we can actually see the results where it then further limits the results to anything that has the word John in it, but it was from Center Cycle Shop. So you can see how you can really drill into the values from that as well. The final thing that I want to show you before I go on to some of the questions that you were just asking me is this idea of scoring. And if there's one thing you take away from this, it's like, please try the scoring, because it's an easy thing that you can do that makes such a big impact on your data. So I'm going to show you an example. If I type in the word Linda here, you can see here, Linda is kind of all over the place. It's in the names. I see there's a salesperson that's named Linda as well that was pretty relevant, so it came up at the top. But I know my users, if they're searching for Linda, they're more interested in customer names that have the word Linda in there as opposed to the sales reps. So what I want to do is I want to do some boosting and say, if you find it in the name field, I want you to give it more weighting than if it was found in another field. So let's go into the portal and see if we can get that working. So let me close this here. And for this index here, the AdventureWorks that we've been using, I'm going to discard I can create something called a scoring profile. And you can have more than one. They're dynamic, so that as you can have multiple different ones that have different types of scoring and weighting systems that you apply to it. And I'm going to call it AdventureWorks Scoring. And just say OK. So I have a little scoring profile. Right now, there's no weightings to it at all. It just uses the defaults. So whenever I refer to it in my searches, I refer to AW scoring. Well, right now it's not going to do anything, but as I start adding some scoring functions and weights, it will leverage that. So if I go back to the code, all I need to do is, actually I'll just copy the line so I don't make a mistake. Over here, stop it so I can actually make the change. And say scoring, why is the tabbing so bad? So I'm going to say for this query, I'm going to leverage the scoring profile called scoring, AW scoring, which is what I just created from the portal. So if I run this, it'll leverage it, but it'll look like the exact same results that we saw before. It'll still show Linda in the exact same order, which I'll verify. Which it does. Linda's still showing as a salesperson the second result. So let's go to the portal and actually add in a text weight. So I'm going to go in here and I'm going to say, if you find it in the first name, give it a boosting of, let's say, 10. And same thing for last name. I'll make that, 8. And over here for company name, if you find it in the company name, that's a 10 as well, because that was a pretty important one. So I can say save right here. That instantly applies it to the index. And if I do a search for Linda again, we can see now the ordering is slightly different. Now, the Lindas that have valuable names are all at the top of the list. And only when we don't actually find one in the name do we then go to the salesperson. So you can see from the text weighting how it's very easy for you to add these different ones. And you might have some that are for salespeople, some that are for accounting, have different weighting based on what they're interested in. Maybe a manager would be interested in more boosting based on the salesperson's name. And there's a lot of other really cool things that you can do from this. So if I close this and I can add in add scoring, and there's a bunch of different types of scoring functions I can do. Magnitude is something where you can choose an integer field and then do boosting based on that. Imagine you had a rating field, and it was if somebody could rate it from 1 to 5. You could say if it's a 5-star rated item, that gets boosted more than a 1-star item. And you can do all kinds of different degradation. So you can make it so that it linearly degrades from 5 to 1. You can make it constant. You can also make it logarithmic so that it drops off sharply, so it gets very little boosting at the start or the end. You can do it based on freshness. Remember that example I was telling you on with the knowledge base articles? If you wanted to boost it, a more recent document, something that has a timestamp field that has a more recent value, that gets more weighting based on what value you gave than something else. Distance is where we use geospatial. And this is something that you can just do. If you can take the user's location, and most devices now give that to you. It gives you, the location of that user. You can say, if you find, based on that location that's being passed in the query, if it's in closer proximity to that point that you provided, then it gets more weighting. And this is something that you can do so that it actually applies it based on, your own location. If you're in New York City and you would do a search, you may get very different results than if you go into, say London and do a search from that. So you can actually use the location to do boosting. And tag boosting is probably the most extensive one, where you can actually apply tags to your documents. And then if you find a matching tag based on what you pass in the parameters in that document, you can actually boost it. This is great for sponsored listings, or if you have salespeople that you wanted to tag those companies with, you could do that as well. Okay, so that's enough of that. I wanted to just kind of finish off with two things, and yeah, question. Do we have what? Dynamic fields. Sorry, let me just go up here for 1 second. So the question was, do we have dynamic fields? And the answer is no. You have to define the fields. You can add fields dynamically to the search index, so you can make incremental additions. But it's not like DocumentDB, where it's a true JSON store, and you can have different structures for each of your documents. For us, you need to define the structure of that index, and you can add to it, but you can't. It's not the level of dynamic like DocumentDB. In fact, that's why one of the reasons why we added the indexer, because they actually work really well together for one of those reasons. Yeah, Ron.
So if you're going to update a production site with something on it, is there like a hot switch sort of between? So if you want to create a new index with some sort of like new capability, or you search over a new field,
Yep.
and you have to recreate that and then upload again, is there a good way to like hot switch that, or is it purely just you should go through like button configures?
Yeah, so just to repeat Ron's question, so what happens if you're doing a new version of your index, or you need to make changes, you need to swap over in your production environment to a different index or a different change? And there's kind of a number of different ways. Sometimes, some people will actually just add new fields into their existing index that represent the changes that they made, and then just simply null out the original values once they no longer need it. And from a search perspective, that's actually pretty fine, because we, for blank spaces, we handle that really well. So that's one approach. More often, it's what I think is what you're talking to, which is where you actually just create a second index in your search service, call it index v2, with the new schema that you want, and then just refer to that new index once you're ready. We don't have any automatic switching, perhaps like you would see with VMs, where you could have, your production one and a staging one and swap it. We don't have that. Okay? Yeah, one question.
Yeah, so if you wanted to search across a couple of indexes, is it a search index 1 and then do a similar type of call to index number 2, or how would that work?
So I just want to make sure I understand your question. Are you interested in being able to do joins across indexes, or is it?
Not really.
Okay.
If I'm looking for John,
Yep.
it might be an index 1 or it might be an index 2, like a totally different
I get it.
that has John in it, right?
Okay.
It might be customer, or it might be location or something like
Yeah.
that.
Okay, so I'm going to repeat what I heard, and please tell me if I get it wrong. So what happens if you have one index that you might be searching for that has John, you have a second index that has John in it, in a different index? How do you handle that type of thing? Did I have that correct?
Yeah.
Okay, so in that case, you're right. You could do it and do a search against index 1 and then a search against index 2 and merge them, but that doesn't work very well in search. And the reason why that is because the results that come back are given a score. So when we look through it, we say, okay, this document gets, say, like 3.2, and another one gets 2.8. And the higher the score, based on all this complex things that we do, the higher the score, the higher it will be in the search results. So if you do that against one index and you do it in another one, the scoring numbering that gets used can be very different. So when you get them back, you may merge it, and it might say you might get all of the values from index 1 and then only some for index 2. So that doesn't work very well. So what we recommend that people do in that case is often you can actually have both pieces of data in one index. So let's say you have all of the fields from index 1, right? And then you have all the fields from index 2. And so you can imagine there's probably going to be this huge chunk where there's all the data, and then over here it's just all blank space. There's no data. And then down here for the other fields, there's all blank, but then it's all the data for the other one, right? And I know you DBAs are probably like going, that's killing me. Don't do that. But in search, because it handles these blank spaces so well, like that's what you do. You just put it all into that format. And the beauty of that is that it allows us to do the scoring based on all of the content. And you don't need to do two searches. So I realize it's not always possible to do that, but that is the most common way. And I apologize to DBAs because that's probably giving you a heart attack right now hearing that. But that's how that works. I'm going to take one more question, and then I'll leave it. Sorry, I'll do you. I promise I'll get you after. Okay, sorry. Question. Mm. Yeah, so I want to make sure I heard it correctly. So if you look at things like Elasticsearch, you can do cross-index queries. Even things like aliasing is a common way of doing that. We don't expose that yet. And we've done that because, we didn't see a lot of need for it yet, but the cross-index querying is something that's coming up enough that we think that we will expose it. But you're right. We don't always add in every capability. We've tried to do it in such a way that hopefully it's a fair bit simpler because we only expose what we see in these key scenarios, but then it's very easy for us to add one. And cross-index querying is one that we hear common enough that we are looking to add, and that's why the feedback from each of you is pretty helpful to it. And I apologize, I'm going to hold off the questions until the end just because I want to answer some of the other things, and I want to show you this cool Cortana thing. So there was a question on the multi-language support, and this is an interesting area for us because if you think about multi-language search, it's actually a really, really tough problem. When you think about things like handling spaces, if you're looking for Windows Phone, is it Win Phone? Is it Win Space Phone? Is it Win Phone all one word? And then what happens if you do it in Japanese, where they don't actually have spaces, and you move one character on the other side has a completely different meaning? And then I think there was a question over here about handling accents. Sometimes in some languages, if you type in a letter, sometimes they do it with the accent, sometimes they don't. There's the masculine forms of the words, feminine, the plurality. All of these things get really crazy hard really, really quickly. And so that's one of the reasons why we've tried to make a big focus on this. And so what we started with is we actually took the Lucene analyzers. Lucene is an open source technology that is part of Elasticsearch. It has a really great support for 27 languages, and it does things, it's called stemming. So it's kind of a heuristic way of finding maybe the plurals of the word. So if you look for, swimming, you can find swim. So it kind of is a more heuristic way. So it's really, really good, and we added that as a start. But the other thing that we have just fairly recently added is what we call the Microsoft analyzers. And this is something we stole from the Office and Bing team. They've been using it in their platform. Well, Office has been using it for over 16 years. It has support for over 50 different languages. And to your question, it does support the lemmatization. Lemmatization is something that's really interesting because it requires us to have a deep understanding of each of those 50 different languages. So if you search for the word, mouse, we can find the word mice because we understand it's not, you can't get mouse to mice by just heuristically just chopping it off. You have to understand it. For the accents and the characters and the plurality and the masculine and feminine tenses of those languages, we handle those pretty well. We even do things like, names quite well, so that, different forms of that. So for me, this is kind of an exciting time because up until our first version, what we've been trying to do is add in an easy to manage service, scalable. It does all the things that you want pretty easily. But now we get to start adding in these cool things that no search technology has ever been able to really offer. And this is one of them that we've been doing. There's a number of other different things from Microsoft, from areas of recommendations. So if you're searching for something and you want to recommend similar items, there's some really cool things from machine learning that we've been doing so that you can learn based on what people are searching for so that you can get smarter and smarter indexes that provide results. So these are the things that we can add on top of the search that make it even more effective. And for my last few minutes, since I'm really running out of time and I really want to show you this, I want to show you a completely different way of kind of looking at search. So what I'm going to do is, hopefully you can see this okay, is I have this Windows Phone application. And so unlike the last one, which was an MVC application, this is actually a Windows Phone version of mine, once again with my really crummy UI skills. I wrote this so that, actually I shouldn't say I wrote it, I stole it from our engineers and I modified it slightly. But the idea is that I want to make it so that I can search for my customers right from here. So I can go in here and, let me just bring it up here. There we go. So I can type in John and search. So it's going out and doing my search for it. And by the way, this is using the exact same .NET SDK. But the other cool thing that we can do is I can do Cortana. Adventure. Find bicycle. So you notice it's starting up the AdventureWorks application. It's taking that and it's finding search results based on that index that we just leveraged with the word bicycle. And by the way, it's using that stemming that we're just looking at where we found bicycles rather than bicycle. So we can still get the results. We can click on it, get all the details of it, et cetera, et cetera. So this is kind of a new, interesting way of thinking about search because you can very easily add this capability into your application. And if I have a few minutes, I'll actually show you some of the code behind it. All you need to do is provide some of the commands that Cortana is going to expect. And then if it heard the word adventure, I don't know if you heard me say adventure, it knew to launch my application. It passed me what was said. I use that in my search, and I just bring the search results back. So there's no real magic to it. It's just leveraging text or speech recognition, extracting that, and then applying it to the search. Okay? And I'm going to just take 1 minute and show you the code from that. And then I want to make sure that I have time for questions. This is all I need to do. So for the text here, the command prefix, so that Cortana, whenever it hears the word adventure, is going to call my application. It's going to load up this page from it, and it's expecting things like me to say, like, find customer name. And it takes whatever I said and passes it to my application in here. And when the application gets loaded, it grabs in all of these commands that were passed in, and I do the search. Okay? Since I don't have much time, hey, thank you. Thank you. By the way, if you are interested in giving this a try, I put it up onto GitHub. So I have a GitHub link at the end of my PowerPoint here that you can just go to and see it, and I can share it to you as well. So if you want to give this a try, it works awesome in Windows Phone. In Windows 10, it's going to be even better. So there's going to be a lot more capabilities. So looks like I have 6 minutes left, so I'm going to stop right there, and I want to make sure that I have time to answer any more questions that you might have. So I'm going to start with you.
Is it possible to create custom fields? For example, if I want to have a hierarchical facet, I can achieve this by implementing my own protocol in the string field. But I've seen it's a class, so is it extensible?
Okay. I'm going to repeat the question. So is there the ability to handle custom fields? And the example you gave was a hierarchical list. So we quite often see this in JSON where maybe you have an address class, and then maybe within that you have multiple phone numbers, and then it kind of goes down in a hierarchy. And so no, you can't do that with Azure Search. That's a great reason why people continue to use DocumentDB along with Azure Search, because it allows you to do that type of thing. And usually what people do is they simply flatten the structure of that so that, rather than having the, customer.first name, you just call it customer first name. And that's a string field, or maybe it's a collection that has a comma-separated list. So that's how you handle it in Azure Search. There's a really good blog post that I can point you to after on how to actually do this, how to flatten the structure of your JSON to make it work in Azure Search. If you're interested, I can point you to after. So hopefully that answered your question. Yes?
I apologize, I missed it in your earlier example. But you're getting a result set back from search.
Yes.
And then in your example, you were basically parsing through that, turning it into an HTML table.
Yes.
What is that result set? Is that JSON that's coming back?
Okay. So the question is like, I really whipped through it really quickly, so I apologize. But the question is, you do a search, and you get something back, and you iterated through it, but it wasn't obvious what it was. And yes, it is a JSON document that you get back. And so when you get the results, there's a number of different things you get. You get documents. So each result, based on the specified number that you've told us to send back, there could be, say, 20 documents. And then so when you go into that JSON document, you can iterate through each of them. And each document has all of the field name value pairs of what you have. And similarly, there's things for facets. So for all of the different facets, you can drill into them and then iterate through all that. We can provide the counts and things like that. But to answer your question, yes, it's a JSON document that you iterate through.
Beautiful, thank you.
Yeah. Good question.
So everything you show in facets, it's already available?
Yes. So, sorry. Everything you showed, including facets, is already available. Yes. Everything I showed to you today is available. Yep. And even that Windows phone, you can do this today. Yeah. Question at the back. So you asked about if it supports secure search. I'm going to admit I don't actually know what that is. I will say that. Sorry. So the question was on security and entitlement. I've often heard people refer to this as secured trimming. Yeah, exactly. So I'll tell you where we are right now, and then I'll tell you what we're looking at for the hopefully near future. So right now, the way that people handle this is through our filter capabilities. So you can add in fields, maybe even a collection field that lists their security privileges. And usually at the mid-tier in your application is where you handle the authentication and you validate who they are. And then from your mid-tier, you do the searches, but you say do a search where this permissions field equals some value. And then you do it that way. That's where we are today. We are very interested in seeing if there's things that we can do. So far, we've heard things like tying it into Active Directory, so that you could actually leverage your Active Directory and the credentials there to limit access from that point. Just to be clear, that is not something we have today, but it's something that we're very interested in looking at for the future. So for today, it's a level of it's almost like you write your own filtering in the search. Okay, question.
Now we have Azure search and we do have SharePoint search.
Yep.
Just wondering whether there are any ambitions to bring it together or whether there are collaborations between teams.
Mm-hmm.
Completely separate technologies. Maybe you can elaborate a bit on.
I'm glad you asked that. I was waiting for somebody to ask that. I knew someone would ask it. The question is, okay, SharePoint search, Azure search, what's going on? Are you going to combine these? What's the difference is in that point? And so, how much time do I have? Let's see. So I got 1 minute, so I'm going to do a quick answer. So SharePoint is based on technology called FAST, which was an acquisition that Microsoft made quite a few years ago. And when we first created Azure Search, the core of our search was FAST. And we started with that because it made sense to leverage it. But what we found as we moved forward is that there's actually differences in the workloads that we see from the SharePoint environment, which FAST focuses on Exchange Online and SharePoint. So if you think about SharePoint, what happens is there's a lot of content going in. Not a lot of searches necessarily, but a lot of content going in. So they've optimized it for that type of environment. Whereas for us, we need to support Hy-Vee that can have hundreds of queries per second, right? We need to support, these other companies that can get into thousands of queries per second. They don't have necessarily that huge amount of document content, but the query load is different. So we found that there was enough differences that it wasn't viable for us to leverage that. And we worked with the FAST team, and we both agreed that. So that's why we actually chose to use Elasticsearch, which I actually think is really great. So that's the reasoning why we got to where we are. But we are looking at different ways of kind of tying them together so that we can leverage a lot of the same capabilities and do it. And I think that there was a great question about indexing content from SharePoint. So don't know if that answered your question very well, but that's kind of where we are, and that's how it got to where it is.
One follow-up on this.
Yeah.
Are you planning to extend the Elasticsearch-based Azure search for full text search capabilities? You just mentioned briefly before, which means right, ticker tag and so on, right? In the full text, which is where SharePoint search is living from. Are you going into this direction as well?
So yeah, so the question was, about the content, they can ingest content. Yeah, and I think there's going to be some overlap on some of the things that we do, some of the things that they can do. I believe SharePoint is incredibly strong at the enterprise connector level. It's got things like the security authentication that's really built in very strong. It's got a lot, these connectors that make it very simple for you to just scan through file systems and ingest it. So I guess there is a little bit of an overlap to it, but I think that for us being, since we're focused very much on those scenarios that I told you, which is it seems very different than what SharePoint offers, I think that there's enough differences there. Sorry, yeah, let me, so it looks like I'm done. I think I'm going to get kicked off any second now. So I am going to, so I think in the PowerPoint, I assume that you can download this. This is where oh my gosh, if I actually show it to you. Here are all the links from the demos from today. Let me just I'll let you take the picture of that. But please, you download the PowerPoint from this. If you can't find it, email me at liamca@microsoft.com, and I will provide it to you if you don't get the PowerPoint or anything like that. So I'm out of time. I'm going to stick around for as long as you want. Thank you very much for your time. I appreciate it. Thank you.